Hi guys, I'm back, and now we're going to start looking at how we solve equations with fractions and powers. So we're looking at what they're called as rational exponent equations, solving equations with rational exponents. So very quickly, I want to review with you what that means. So if you see this x to the 2/3 power, we've looked at writing it different ways. It's the same as x to the second power to the 1/3 power. Or you could say x to the 1/3 power squared. But if you recall back to when we learned this in the beginning, we talked about this being the exponent or the power, and the 3 is the root. So I can also write this as the cube root of x squared. And so different ways to think about it are going to help us when we're solving equations that involve this. Okay, so let's go to the next slide and do some examples. Oh, maybe. There we go. Okay, so here we're looking at our thing with that rational exponent is right there. And what we really need to do is we need to kind of treat this a little bit like the square root method and get this thing by itself. So to do that, I'm going to add 25 to both sides. That's going to give me 5x to the 3/2 equals 25. Now I'm going to divide by 5. And that gives me x to the 3/2 equals 5. Now, if you really think about what I have here, what I have is I have the square root of x to the 3rd equals 5. To undo this, to make this just an x, I'm going to start with the root. To get rid of a square root, we square. So what I have left is x cubed, the square root and the square canceled, equals 25. Okay. To get rid of a cube, we have to cube root both sides. And so I have x equals the cube root of 25. I have been having you put plus or minus when we square root, but we do not put plus or minus when we cube root. In fact, the only time we put a plus or minus is when my root is an even number. So I would plus or minus a square root. I would plus or minus a 4th root. But odd roots, we don't plus or minus. So this would be the solution I would be looking for. I would like you to try to break them down, but if you remember, 25 is just 5 times 5, so I don't have 3 of anything, so I'm just going to leave it like it is. For this one here, we're going to now isolate x to the 2/3, kind of like the square root method. Get that x isolated. So we're going to add 8 to both sides. So what I end up with is x to the 2/3 equals 4. Okay, so let's rewrite this. The cube root of x squared equals 4. First, I'm going to get rid of the root by taking it to the 3rd power. Okay, so the cubes cancel. The cube root and the cube cancel. So I have x squared equals 4 to the 3rd is 64. Now I'm going to square root. Okay. Well, the square root of 64 is 8. Because I did an even root, I have to put a plus or minus in front of my answer. Okay. Last example, I'm going to add 1 to both sides here, but that's what I'm going to do before I stop. So when we had problems like this, we didn't subtract the 2 over, we just went ahead and square rooted once the parenthesis was done. So this is kind of the same thing here. I've got to isolate this whole thing because this whole thing is to the 3/2 power. So x squared minus 3x plus 3, now to the 3/2 equals 1. I'm going to rewrite this as the square root of x squared minus 3x plus 3 to the 3rd power equals 1. I'm going to start with the root. I'm going to square both sides to get rid of the root. X squared minus 3x plus 3 all to the 3rd power equals 1. Now I'm going to cube root both sides. Okay. Since I'm cube rooting and that's an odd number, I don't need to use plus or minus. So what I have now is x squared minus 3x plus 3 equals 1. Cube root of 1 is 1. Now it's a quadratic, so I need to subtract the 1 and solve. What are two numbers that multiply to be 2 and add to be negative 3? X minus 1, x minus 2 equals 0, so x equals 1, 2. That is the last example I have for today. I hope that these videos were informative, and we will continue our discussion in class tomorrow.